Hi everyone, welcome to Science class, Physics chapter 12, Sound part 3, and today's topic is the characteristics of sound waves. Before going to understand new characteristics of sound wave, let us have a recap of previous video. You have learned sound needs a medium to travel and sound waves are longitudinal in nature. You have learned the meaning of longitudinal waves as well as transverse waves. In longitudinal waves, each particle vibrates parallel with respect to the direction of wave propagation, whereas in transverse waves, each particle vibrates perpendicular with respect to the direction of wave propagation. After this, you people have learned the characteristics of sound wave. There you have learned four characteristics. First one, oscillation. The to and fro motion or back and forth motion of an object is called oscillation. The second characteristics what you have learned is wavelength. The distance between the two consecutive compressions or two consecutive rarefactions is called wavelength. And the third one you have learned is frequency. The number of oscillations per unit time is called frequency. The fourth characteristic is time period. That is, the time taken by two consecutive compressions or rarefactions is called time period of the wave. And the relation between frequency and time period also you have learned, that is nu is equal to 1 by t. Nu you are going to denote as a frequency, time period you are denoted as a t. So nu is equal to 1 by t is the relation between time period as well as frequency. Now let us move to a new topic, that is a characteristic of a sound, pitch. Pitch is basically determined by its frequency. So it is defined as the quality of a sound governed by the rate of vibrations producing it. That means the faster the vibration of the source, the higher is the frequency and the higher is the pitch. Thus, the high pitch sound corresponds to more number of compressions and rarefactions passing a fixed point per unit time. Objects of a different size and conditions vibrate at different frequencies to produce sound of different pitch. Children, observe figure 1 where low pitched sound is showing you people only 3 compressions and 3 rarefactions, whereas high pitched sound is showing more than 20 compressions and 20 rarefactions. In figure 2, if you observe a graphical picture where 2 compressions and 2 rarefactions is shown by low pitched sound, and in high pitched sound it is shown 8 compressions and 8 rarefactions. This is how we can differentiate between low pitch and high pitch. Here is a simple example. A violin and a guitar played at the same time, but the sounds we receive are different because they have different pitch. Compare the frequencies of a sound with the same loudness. Observe the figure where lower pitch sound has a lower frequency and high pitch sound has a higher frequency. The next characteristic of sound is amplitude. The meaning of amplitude is the magnitude of the maximum disturbance in the medium on either side of mean value is called amplitude. Or in a simple statement, the maximum displacement between mean position to the extreme position of a particle in a wave is called amplitude. Even you can define as the maximum extent of a vibration or oscillation measured from the position of equilibrium. And amplitude we denoted by a letter A, and its SI unit is meter. Follow both the animation, children, where the middle line is showing about a mean position and both upper side and lower side is showing extreme position. And definition as says the distance between mean position to extreme position is called amplitude. Similarly, in the next figure it is showing about how the particles are moving and having high amplitude and low amplitude. In the figure 2, the first one is showing higher amplitude and the second one is showing lower amplitude. The next characteristic is loudness or softness. Let us understand the meaning of loudness and softness. The loudness or softness of a sound is determined basically by its amplitude. The amplitude of the sound wave depends upon the force with which an object is made to vibrate. And a sound wave spreads out from its source. As it moves away from the source, its amplitude as well as its loudness decreases. Higher the amplitude, louder is the sound. Lower the amplitude, softer is the sound. We can observe in below figure, there is the first one soft sound. You can see its amplitude is less, so it is a soft sound. And the next figure where the amplitude is more, so it is called as louder sound. Let us move to the other characteristic, that is timbre or quality. It is the characteristic which enables us to distinguish one sound from another having same pitch and loudness. For this I would like to give an example. If you call to your friend's house, you will identify whether your friend is speaking or your friend's mother or father. Easily even you can differentiate between the voice of a male or female child or an adult. This is what the quality or a timbre we refer. Let us understand some more important topic related to sound. That is, one is music, noise, tone and note. Let us go with the music. The sound which is more pleasant is said to be of a rich quality is called music. You have learned all these things in lower classes. About noise also, that is unpleasant to listen is called as noise. Let us discuss the next one, that is tone. A sound of a single frequency is called a tone. Any single frequency we refer that as a tone. And the next is note. Note for sound waves. It's not like an important note. It's a note related to sound wave. The sound which is produced due to a mixture of several frequencies called a note. In the below figure you can observe tone and note. Here left side figure it is shown pure tone which is called as even a sine wave, and right side figure it is shown a tone, a single wave and a noise. Dear students, observe the given table clearly where characteristics like loudness, pitch, quality or timbre is given. First one is loudness. Easily you can identify the difference between soft sound and loud sound which are depend on amplitude. And the next characteristic about pitch, where easily you can observe low frequency as well as high frequency sound which we call as a low pitch, high pitch which are depend on frequency. And the next one is quality or timbre. Clearly observe two waveforms. One is a single wave, another one is mixed wave, where you can differentiate between two different type of sound waves. Now let us understand the difference between loudness and intensity. We sometimes use the term loudness and intensity interchangeably, but they are not same. Let us understand first the meaning of intensity. That is, the amount of sound energy passing each second through unit area is called the intensity of sound. I repeat, the number of sound waves passing in unit area in each second is called intensity. Whereas loudness is measure of the response of the ear to the sound, because loudness depends on amplitude. If you apply more force, you are creating more amplitude. So only it is called as the response of the ear to the sound. A simple example is given. When two sounds are of equal intensity is given, then we may hear one as louder than the other just because our ear detects it better. So this makes you understand how intensity is different from loudness. Now let us understand the speed of sound in different media. Sound propagates through a medium at a finite speed. The sound of a thunder is heard a little later than the flash of a light is seen. So we can make out that sound travels with a speed which is much less than the speed of light. The speed of sound depends on the properties of a medium through which it travels. The speed of sound in a medium depends on temperature of the medium. That means if the temperature varies, speed of a sound also Whereas the speed of a sound decreases when we go from solid to gaseous state. In any medium, as we increase the temperature, the speed of sound increases. For example, the speed of sound in air is 331 meter per second at 0 degrees Celsius and 344 meter per Celsius at 22 degrees Celsius. Here is the table which gives you speed of sound in different medium at 25 degrees Celsius, and the table has solid state, liquid state, gaseous state, some examples. In solid state, aluminum has the most speed, that is 6420 meter per second. The sound travels in aluminum 6420 meter in 1 second. Similarly, in liquids, water, especially seawater, the speed of sound is 1531, that is 1531 meter per second. As well as in gaseous, in hydrogen it is 1284 meter per second, whereas in air it is 346 meter per second. Generally, we are going to deal with air for many numericals as well as day-to-day life. So we consider the speed of light in air as 346 or maybe 340 meter per second, which is depending on the temperature. Dear students, in this video, you people have learned four characteristics, that is pitch, amplitude, loudness, timbre, as well as the speed of sound in different medium. In next video, you are going to learn the last characteristic, that is how to calculate the speed of sound. Take care and solve the next worksheet, that is worksheet 3. Worksheet 3. Question number 1. Define amplitude, write its SI unit. And the second one is differentiate between loudness and intensity. Third one is draw the diagram of low pitch and high pitch. Fourth one is draw the diagram of soft sound and loud sound. Fifth one is which way property determines loudness as well as pitch. To answer these questions, watch the video clearly. You will get answer for each question. Take care children. Bye.